Assalamu alaikum wa rahmatullahi wa barakatuh. Today, inshallah, we will continue the revision of the AC circuit we have started last class. We will start with the part of power factor. First, this is our objectives during the class today, and next two classes, inshallah, we'll discuss the power factor correction. What is the meaning of power factor correction and why we need to correct the power factor of loads. We'll review the three-phase systems, the different connection of three-phase, the transformation between the different connections, star and delta or Y and delta, and review the power measurements, how we can measure the power of a three-phase systems, either balanced or unbalanced system. Shabab, can you hear me?
Yes.
Yes, Doctor, clearly.
And if some colleagues have problems with audio, so it's their own problem, I believe. Fine. Okay. The audio will be recorded also. The class will be recorded, so anyone miss any part, he can listen to it later, inshallah. Fine. So we will start with the part of power. And I received many questions last class, many emails from some of you regarding the meaning, or they are confusing about the meaning of active power or real power and reactive power. And as you remember, we agreed last class that we have three terms of power. And if you remember in the last class, can you see the other screen now, Shabab?
Yes, it is clear.
Yes.
The other screen, which is the reference.
Only the PDF.
No, only
Okay, just one.
the slide.
Okay. Now,
Yes, we can see.
okay, good. We described this last class. We have three terms of power. This is our reference. We have three terms of power, Shabab. These terms are B1, B2, and B3. B1 depends on cosine theta, and we said that this is the average value of power. And we have the second term, which is VP, IP, as a function of cosine theta as well. So it's related to active power. However, it's multiplied by cosine 2 omega t. Cosine 2 omega t is a double of the supply frequency. So the average value of this part will be 0. The average value of this part, which is B2, will be 0. Also, the third part, it's a function of sine theta. So it's not related to active power anymore, because we have cosine theta related to active power, and sine theta will be related to the other part of power, which is reactive power. And it's also function of sine 2 omega t. So the integration also of this part will be 0. Take care, this is instantaneous function. This is instantaneous function as a function of t, or omega t. So if you take the average of this relation for the three terms, the average will be only this part, which is out of omega t. So this is P1. This is mean the real part of a complex number, or the average value of instantaneous waveform. So B1 represents the average value. Right. What about B2? B2 is related also to real power. However, the average value is 0. So it's just some ripples in the power, some ripples in the active power. However, the average value of this part is 0. Okay, شباب? But the last part, which is B3, is related to reactive power, which is a function of sine theta. Right. Also, we described the waveforms of the three terms. And as you can see, if this is a voltage waveform, start at angle 0 as reference, and the current is shifted by the angle theta. So this is theta at that instant, or theta divided by t, or the time related to the angle theta, sorry. So if we multiply voltage and the current together, these two waveforms, we will have the overall instantaneous value of power. So this curve represents the three terms, the sum of the three terms. However, if we analyze this waveform, we can get three different terms, which are P1, which is a constant part, and this is considered as the real power or the average power. And we will have also another other two parts like P1 plus P2. As you can see, this is the two terms together, P1 plus P2. What will be the average value of this waveform? It's a question for you.
I think 0.
Huh?
Average power? The average power.
B1. The average is not 0. Someone said the average is 0. The average of this waveform, which is P1 plus P2.
B1.
يعني امتى شباب we can say the average is 0? The average is 0 if the positive and negative half cycles are يعني similar. In that case, we can say the average is 0. However, this waveform here, it's not 0, huh? مظبوط؟ This waveform يا شباب, huh? There is an average value. What is the average value? The average value is B1. This is right. The average value will be B1. So the sum of the first two terms represent the instantaneous real power. However, the average value of these two terms will be only P1. So this is the representation of real power. However, the third part represents reactive power, which is minus sign like that. This represents reactive power. Type. The meaning, يعني, which is valuable for us, active or reactive power? Let me share the presentation. Do you see the presentation as full screen now, Shabab?
Yes.
Yes.
Good. And as you can see, this cup, we have a liquid here, any kind of choice. And as you can see, we have some foam at the surface. The liquid itself represents the active power, which is useful for us. This is measured in watts. However, the foam represents reactive power. Okay, شباب? The foam is يعني something يعني not important for us. However, in electricity, it helps in power transfer and control power. So what is the capacity of the cup itself? Summation of the two powers, active and reactive. However, the active only is useful. Type, a question, again, another question. Here you can see the liquid surface here is a straight line. صح يا شباب؟ The liquid here appear like straight line like that. But what is if the square, if the liquid surface is moving like waves like that?
AC, it will be like AC.
It's like AC, which means it has some ripples on the surface. Is it right? But
Yes.
still, the average value will give you the same line. So this is the meaning of part P2 in the equation. P2 is just some ripples for power. However, the average value of these ripples will be 0 because the average value of the overall power will be the part of P1, which is function of cosine theta. Right. So this was a very important part, and you have to recognize this part because this is one of the basics of electrical engineering. Power factor improvement. Why we need to improve power factor? Let me describe an example for you. Here we have an inductive load. This inductive load consists of part of active power and part of reactive power. So assume we have P plus JQ, and we will call this part of Q as Q old. Q old will refer to reactive power before compensation. Okay, Shabab? If we need to improve the power factor, first, let me describe the triangle of power for the old case. This is the value of Q old, and this is the value of active power. Assume we have certain load like induction motor or any kind of AC motors. This induction motor has a lagging power factor, so it absorbs a real power which represent the active power or represent the mechanical load on the motor itself, plus the some losses on the motor. Okay, so this represents the part of P, which is the active power, and also due to the inductance of the coil itself, it needs some reactive power. So we have another value of Q, which is Q old. So what will be the total power absorbed from the supply? It's going to be S, apparent power, which is represented by S old equal to square root of 2, P square, which is active power square, plus Q old square. Time. As you can see, which is bigger in magnitude, Shabab, P or S?
S.
S is bigger. This is right. Like, either P or S, both of them are a function, are functions of V and I, voltage and the current. Is it right?
Yes.
However, P depends on the power factor. Type. If you already consume a power with P value, but due to reactive power, you consumed S value, this will increase the current. This will increase the current absorbed from the supply. Because if you only consume active power, the value of S will be reduced up to reaching P. Is it right, Shabab? The voltage is constant. So this means the current will be increased to achieve high value of S because of the absorbed reactive power. So this means extra losses on the cables. Is it right? And this cost the electricity company, this cost is overhead on the electricity company, not the user itself. Because in our homes, we have electricity meters called kilowatt hour meters. So we only pay the cost of P, not the cost of S. Is it clear? So the electrical company makes penalties on people who have a low power factor, which means you consume B and lots of Q, and you pay only the power cost, not the S cost. For that, they make penalties. Actually, it's not penalties, it's the actual cost of power you have consumed. Okay, but we assume it's like penalties because they calculated it because of the lower power factor back. Now, if we would like to compensate this power factor to reach to unity, and this is the optimal case, so we need to add some reactive power from another source. Right. question for you. If we have a value of Q, which is Q old, say for instance, 100 kilovar, 100 kVA reactive, 100 kilovar. What is the optimal value we need to add in order to reduce the current of the supply?
The same but negative.
The same but in negative, which means minus 100 kilovar exactly. Type. So the minus 100 kilovar, we can obtain it from another reactive load, but capacitive one. So we can add capacitor, and this capacitor can add the same value but in negative, because negative means inductive or capacitive. Positive means inductive and negative means capacitive. So the sign of Q just referring to the type. Is it inductive or capacitive type? So we agreed together now, if we can obtain a source for Q, and this Q equal to the old value of reactive power needed in the load, so the sum of the two reactive powers seen from the supply will be 0. And this, in that case, will reduce the consumed current, will reduce the drawn current from the supply. And this is the benefit of unity power factor. However, most of times we cannot obtain the same value of reactive power. So assume we have a value of reactive power from a capacitor, but this value is not equal to the one required by the load. So in this case, we give an example in numbers. We need here 100 kilovar. So if we have Q add with a value of 90 kilovar, so the remainder, which will be supplied from the grid, will be only 10 kilovar. Is it right, Shabab? Or
Yes.
okay,
Right.
good.
Doctor,
Tfaddal.
sorry, I don't know why we have the new and the old.
Again, the old represent the reactive power absorbed by the load. And we need to reduce the current. Why reduce the current? Because we agreed together, we consume P. However, the electricity company produce S. And you can see S is very high compared to P because of the large reactive power used by the load. Okay? You got it?
Yes, yes.
This is for the old case. We need to improve the power factor in order to reduce the absorbed current from the supply. How we can improve? Just adding a capacitor here, which will give part of reactive power to reduce the amount of reactive power taken from the supply. So in a numerical example, if we have 100 kilovars absorbed by the load, and we could obtain 90 kilovars from a capacitor, so the resultant or the absorbed or the taken reactive power from the supply will be only 10 kilovars. Is it right? So in this case, Shabab, in this case, we reduce the amount of reactive power from the supply. So this means the Q new will equal to Q old minus Q added. And in that case, the new power factor will depend on the value of B divided by S new, because after adding Q add, which is in blue color here, the resultant Q will be Q new, which is in red color vector. So the resultant power, apparent power, will be S new. So this will be the new apparent power due to power factor compensation. So the new power factor will be equal to P divided S new, or you can calculate it in different way, which is power factor new equal to cosine the angle, which is this angle. Right. What is the angle as a function of the new reactive power? The function, the angle equal to tan inverse Q new divided by P. So we can say the new power factor equal to cosine of tan inverse of Q new divided P. طبعا شباب, for the new value of S also, we can say S new equal to P square plus Q square under the square root. طبعا Q new square. تمام يا شباب؟ So this is the idea of power factor compensation. Is there any question يا شباب in these parts?
Yes, doctor. About improving the power factor.
Yes, اتفضل.
Take the case that the load is inductive. What if it was capacitive?
Very important question. It's يعني let me discuss it with you شباب. يعني in our grid, what is the majority load side? Is it capacitive or inductive?
Capacitive in the grid.
لا بالعكس. The
Inductive
grid,
majority.
the grid is inductive because where you can find the capacitor loads. What is the capacitive loads in our life? You may find some capacitors in electronical devices, is it right? But even these capacitors in electronical devices are in DC side, not in AC side. However, the overall power consumed in the grid is inductive. Most of our loads are inductive. Lighting loads are inductive. Motors are inductive. Okay, شباب? So most of our loads on grid are inductive. So the power factor in any power station will be lag because the reactive power is moving from the generator side to load side. This is the majority. So we describe the majority case, which is you have inductive load and you need to compensate this power factor to reach to unity. However, your question, if we have certain load with capacitive, with highly capacitive reactive power, and you need to improve the reactive power, you should add inductor. تمام يا شباب? This is just a يعني special case. However, this case does not exist in our life. The majority case, we have inductive loads, and we need to compensate the power factor by adding only reactive power from capacitive loads. Capacitive loads in our life, like what? Like capacitor, static capacitor. Like something else we'll describe, inshallah, in the synchronous machine, which is synchronous motor in mode called synchronous condenser. It can also deliver reactive power. These are the old solution. However, we have most recent new solutions using power electronic converters. Okay, شباب? It's called static VAR compensator. Static VAR compensator or advanced static VAR compensator, which can deliver a source of power just by controlling the zero crossing of current respective to the voltage zero crossing. So it's just a matter of control using power electronics, and you can add virtual reactive power. In that case, we can compensate also the power factor. Right. Is it clear the question for the question who asked it? Now it's clear?
Clear.
Okay. Good.
Doctor,
تفضل.
Q old and Q add have the same sign?
In the previous example here, we said it's different.
So why we add in Q new equal Q old minus Q add? Should be plus?
When we can add reactive powers together. Actually, it's clear here because of the flow. As you can see, if you make node on the figure here, node at this part, what is the flow of Q? How you can Q new plus Q add, both of arrows are go to this point, صح? So
Yes.
Q old equal to the sum of Q new plus Q add. Is it right?
Okay.
So Q old minus Q add will give you the amount of reactive power of Q new. So this is only using node analysis. Type.
So if Q old is positive, Q add is positive also.
لا هي احنا انا I described now for you just by using these arrows here, okay, using node analysis. However, the physical meaning, Q add is capacitive and the Q old is inductive. So you cannot give both of them the same sign. Is it right?
Okay. Yes.
تمام. So we assume Q inductive as negative, so Q added should be positive, or the inverse, Q old in positive, so Q add should be in negative. So we need the resultant value.
Okay.
Q new
Okay.
will equal to Q old minus added Q. Okay.
And the figure below,
Yes.
assume Q all is positive. And Q out is negative, yes?
Positive or negative, just referring to the direction.
Yes. And Q new should be bigger than Q all because we.
لا, it's not يعني it's not a condition. Q new or Q old يعني sorry, you said Q new and Q add or Q new and Q old?
Q all is positive and Q out is negative. When we say Q all minus Q,
Yes, okay.
means Q new is bigger than Q all.
لا يعني تاني I give numerical example to describe it. You have inductive load with Q add equal 100 kilowatt.
Okay.
And you have Q old of 100 kilowatt. And you have Q added from capacitor equal to 90 kilowatts.
Okay.
So inductive 100, capacitive 90. So what will be the resultant?
Okay, I get it. Yes.
You got it?
Yes. Okay.
So the grid will supply the load by only 10 kilowatts. So Q here is the difference between the two other Qs, Q old and Q added. Okay?
We will use the magnitude. Yes.
Exactly.
Okay.
Because Q يا شباب يعني either Q or P are just quantities, it's not vector.
Okay.
تمام؟ يعني P itself is not vector. Q itself is not vector. However, S is vector. Okay يا شباب؟ يعني Q cannot be represented by complex number, or P cannot be represented by complex number. However, apparent power S should be represented in complex number. تمام يا جماعة؟ Okay. So the other case, شباب, if Q added equal to the Q old, in that case, the reactive power taken from the supply, which is Q will equal to 0. In that case, we can succeed in reaching to unity power factor and reducing the current absorbed from the supply to the minimum value. This is going to save a lot from the losses on the underground cables.
By the way, Doctor, is
Pardon?
it difficult to make the power factor unity?
Sure, this is right, but why? Anybody know, Shabab? Why
Okay.
it's not easy to reach to unity?
Maybe because transients.
Because of the load changing, this is one important thing. The other thing, because of the harmonic existence in our systems. Harmonics reduce the power factor. ماشي شباب? And these values are random. It's not يعني fixed values all of time. So we cannot reach to exactly unity for all of time, just because the variable nature of our loads. However, if the load is fixed, so you can reach, you can reach to unity very easily.
Doctor,
تفضل.
does transients also contribute to this problem?
ما هو transient is condition is يعني the same condition like variability يعني transient is not fixed. Is it right? تمام. What's the meaning of transient, شباب? Anybody know the meaning of transient?
It's the opposite of steady. It's something changing.
Exactly. طيب يعني if you have, for instance, if you have motor and you started the motor just from starting, يعني, is it going to operate at the rated speed from the instant of pushing the switch or turning
No, it will
on
take time.
It will take some
There
time.
is transition time.
Yeah. This time is called the transient. So transient, the definition of transient is the time consumed from starting up till reaching to steady state. So this is the meaning of transient. So as a transient also, you have some variables because you didn't reach to steady state yet. Okay, so it's the same case like يعني, variable conditions or variable loading conditions. تمام يا شباب؟ However, يعني, we don't care about transient most of time because transient time is very small compared to يعني, or according to the type of load. Okay, يا شباب? Here is a numerical example regarding the power factor correction. We have a single phase motor. طبعا you don't care here what is the type of motor, what is the connection of motor, don't care about that. We will work with the motor here as an AC load, whatever the type of motor. A single phase motor connected to 400 volt, 50 hertz supply, and takes 31.7 ampere at a power factor of 0.7 lagging. Yani, we have some basics yani, we have to understand. If it is set 400 volt, so what is this value? Is it instantaneous value? Is it maximum value? Is it root mean square value? ها شباب, which value is right? Is it maximum or root mean square?
Peak value.
It's
Peak
VP,
value.
it's VP, peak value.
RMS.
طيب,
I think RMS.
RMS. يعني the right answer is RMS. طب, let me ask you a question. If you have voltmeter or digital meter and measure the voltage on the socket and you found the voltage is 220 volt, what is this value?
RMS.
It's RMS. And
Yes.
we do not consider the peak value. And all of time, يا شباب, peaks are not important. The effective value is important. For that, يعني اصطلاحيا يعني we have to say the RMS is the يعني well-known expression to represent anything in AC. So for any kind of voltage in examples or problems, it should be RMS value. تمام? So 400 volt here is the RMS value of the supply. Right. 50 hertz is the supply frequency, and 31.7 is the current absorbed by this load, and it's stated that power factor is 0.7 lagging. What is required here? Calculate the capacitor or the capacitance required in parallel with the motor to raise the power factor to 0.9 lagging. So it's يعني similar example to what described in the previous slides. We should add a capacitors or one capacitor or whatever the number of capacitors at the terminal of the load in order to compensate the power factor. So in order to calculate this capacitance, شباب, the capacitance or the capacitor itself, it should deliver which quantity of Q. And let's return back again to the example here. The capacitor here is responsible for the value of Q added. Is it right?
So to find the capacitor, we need to find the Q added first.
Exactly,
And
you are right.
calculate the capacitor.
Exactly. So in order to calculate the capacitance value, we need first to calculate the added reactive power required to compensate the power factor to 0.9. So this is the example now. So we have the active power. Is the active power going to be different between power factor at 0.7 or power factor 0.9? Or the active power should be constant for all of cases?
The reactive volume will change.
Constant. Should be constant.
Exactly. Why, ya shabab? Why? Because for instance, we have certain mechanical load is applied to a motor. يعني it's not logic to reduce the mechanical load in order to improve the power factor. يعني power factor is a matter of power quality. However, you have target. The target is to operate the motor, is to operate the mechanical load. So in order to improve the power factor, you cannot remove the load. يعني for instance مثلا سعر البنزين غلي. سعر البنزين غلي. فاحنا ممكن نعمل كومبنسيشن في الايه في السياره بحيث ان هي تستهلك بنزين اقل. لكن مش ممكن اقول لك اقعد في البيت ما تنزلش تشتغل علشان سعر البنزين غلي، صح ولا غلط؟ يعني الفانكشن التارجت بتاعتنا لازم تتعمل اللي هي ان انا عندي هنا موتور ولازم الاكتيف باور دي تروح للموتور عشان اقدر اشتغل. مظبوط؟ So for all of cases for power factor improvement the active power should be constant. تمام؟ For the load you shouldn't change the value of active power of the load. طيب, so we can calculate P simply by VI multiplied by power factor. So V root mean square is 400, I root mean square is 31.7, and the power factor in the beginning was 0.7. So the amount of active power absorbed by the load is 8876 watts. Right. In order to calculate the added reactive power, you need to know the value of Q old, which was absorbed from the motor at 0.7 lagging power factor, and you need to also know the value of new reactive power absorbed from the supply at 0.9 lagging power factor. Is it right? So we need to calculate Q inductive, which is Q old, and also calculate Q new and use these two values to get the added Q through the capacitance. So Q inductive, which is the Q old for the motor, equal to VI sine theta, and theta equal to cosine inverse to the old power factor. So simply it's 400 volt multiplied by the same current multiplied by sine to cosine inverse of 0.7 power factor. So this is the old reactive power used in or absorbed from the supply. Right. To get Q added, as we described, we need first to calculate the new reactive power absorbed from the supply at 0.9. So simply, you can calculate Q new as P, because P is constant for the all of cases before and after compensation, multiplied by 10 cosine inverse new power factor. Do you know from where you should have this relation? We described this relation, I believe.
This is from the triangle.
Yeah, we describe it here. Yeah, from the triangle here, we describe it. Is there any question? Is there anybody and do not know from where we get this equation? Is it clear? So we can say add a new Q equal to P, which is the same active power, multiplied by 10 cosine inverse 0.9, which is the new power factor. So now this is the value of reactive power taken from the supply after compensation. So the reactive power should be obtained from the capacitor, should be the difference between these two values, 4298 and 9055. So the amount of added reactive power will be the difference, with which is 4756 bars. تمام يا شباب؟ طبعا we agreed together from the last class. The active power is measured in watt, the reactive power is measured in var, and the apparent power or total power measured in volt ampere. So the capacitance can be calculated easily from the basics. You know the relation between the capacitor and the reactive power absorbed or given by the capacitor. So Q equal to V squared divided XC. Is it right, Shabab?
Victor, I have a question here.
Fadlan.
Now here V, you assumed V is constant, right? It
We
will be
assumed
V, the voltage.
yes.
Should it be changed now? By now, because we have the capacitor.
طيب يعني good question. يعني I يعني just asking this for you. شباب هو احنا دلوقتي هنا بنعدل في مين؟ طب تخيل انت عندك كده في البيت، يعني you have the supply voltage at home which is 220 volt. يعني the same example, what is the target? You need to improve the power factor. Is it possible to say for you لا يعني in order to improve the power factor I will make the volt for you 180 instead of 220. Is it possible or logic? We cannot do that. يعني we have
We'll change
some
the real
concepts.
power.
Yeah, we have some basics. The basics, you shouldn't change the voltage of the supply. Voltage of supply is very critical. And you know, in some grids in Europe and the States, if the voltage reduced less than, for instance, 5%, it may damage some devices. The electricity company is the first one responsible for this, and they pay for any damaged device if this has happened. So it's very important to keep the supply voltage constant. This is number one. Number two, if you have a look to the circuit here, the voltage is V here, is it right? So when we add capacitor here, it's going to take some current. So it's expected that the current absorbed from the supply will be different, not the voltage. بس ده ما يغيرش المعنى بتاع in power stations يا شباب, in order to regulate the voltage of bus bar, we have to control the reactive power. This is only during transient يا شباب. يعني we will describe this in details إن شاء الله in the synchronous machine. ماشي؟ حتة ال voltage regulation وإزاي يعني how we can use reactive power in order to compensate the terminal voltage of the generator. ماشي؟ and this is another issue. However, for the supply at homes, the supply should be constant for all of time, and we call it as grid voltage or infinite bus. And we refer all of time to infinite bus. Infinite bus means constant voltage and constant frequency. And this is the aim for any grid. You should keep the frequency and voltage constant. تمام يا شباب؟ However, the current is load dependent. The current change according to the value of load. طيب.
Doctor.
Yes.
Q add, is it always positive?
يعني تاني يا شباب حته positive or negative دي مساله نسبيه. يعني احنا المهم تفهم المعنى. يعني we said in numbers here in this problem the amount of absorbed reactive power for the first case was 9 kilowatt, and we said the capacitor will achieve or supply 4.7 kilowatt. So the amount of reactive power will be obtained from supply should be the difference. Is it right? Because the absorbed from the load should be obtained from both capacitor and supply. تمام?
Yes.
Okay. So after calculating the value of Q added, which is related to the capacitor, we can simply say Q equal to V squared divided XC, and you know XC equal to 1 divided omega C. So simply you can apply, you can substitute with value of frequency and voltage and using the value of Q in order to get the capacitor. And here the capacitor is 94 microfarads. So this is just some notes about power factor compensation. And the time is due now. Inshallah, we can continue by the next class. أستاذنكم بس شباب يعني for the attendance, everybody should write present. Okay. Write present now. Write present on chatting. Okay.
Inshallah. Doctor,
تفضل.
tomorrow, Wednesday, the meeting will be in Zoom or
we will continue this week in Zoom, okay? And inshallah, at the weekend, I will fix the problem of Teams, and I will inform you also through Blackboard.
Okay, thank you.
Okay, thank you.